All right, folks, Mr. Walker coming back to you today. We are going through our final round of constructions. We're talking about altitudes. So let's go through and talk about the definition first. An altitude of a triangle is the perpendicular segment from the vertex of the opposite side that contains the opposite side. So we're going to be going from, in this case, a point that's not on this segment and drawing a line through it that makes a right angle. Now, if this were a triangle, this point here, P, this would be our vertex. And this side here, this would be the opposite side to that vertex. Now, we're going to hook up our camera. We're going to take a look at an example, and then we'll hop back into it and talk about it. All right, folks, we are constructing the perpendicular segment of a line from a point. Now, this is part of the altitude note, so please make sure that you go through and write this on the right paper. All right, first off, we're going to be taking our compass and we are going to be putting it on point P. This time, I'm going to use my metal compass. If you're using the circle compass, I'll make sure I use the right terminology to keep you in the loop, okay? So first off, we're going to put our compass point, the metal side, on P. So here's P. Now, I'm going to make an arc that is going to intersect with the line segment that we have currently, okay? Now, as for the size of it, it does not specify size, so just make sure that this arc will hit over here, okay? Now, when we go through and make this arc, let's make sure I got this right, I believe. I don't necessarily need to connect it, but I do need to make sure that it hits both sides. So here's my arc. It did hit both sides of what we had here. Okay, now the two places that this intersected at for me, we're going to call X and Y. So I made an arc that intersected the lines. I labeled X and Y. We're going to take our compass point and we're going to place it on X and set it to more than half the distance to Y. And we're going to make an arc below the segment. So here's X. I want this to be more than half the line, so this is fine. If I wanted to make it smaller, it should be okay, but I'm going to stick with this. So what I'm going to do is I'm going to make an arc below the segment, so it's going to be down here. Now, without adjusting our compass, we're going to come over to Y and repeat the same thing that we just did. So here's Y. Slang it right there. Now that we got this, what we're going to do is we're going to draw a line from P to that intersection we made down there. And what we just did is we created a perpendicular segment. Now, this kind of looks like part of the stuff that we did for a perpendicular bisector, but this line here that we just drew from P to here, this doesn't cut the line in half. It just makes a set of right angles. Like if I go through and measure this out, this measures out to a 90-degree angle, okay? Now, that's all we're doing with this, all right? Appreciate you watching. You have a good day. All right, folks, welcome back. Let's go through just a quick recap. You go through, and this is going to mirror a little bit of what we had for our perpendicular bisector notes and our angle bisector notes. So we make this arc. That's going to make two small places right here where we adjust the compass to a little more than half of that segment that we have right there from X to Y. We set up two arcs below it, and then from that point that's off the line to where those two arcs cross, we just set up our line there. Now, if you run with a protractor to the line that you made, you'll have a line that is about 90 degrees meeting at, sorry, not a line, an angle that is about 90 degrees. Sorry about that. All right. Now, along with altitudes, we also have another point of concurrency. So there are three altitudes in a triangle, and the point where they intersect is called the orthocenter. So for here, we have three altitudes, one coming from B to the other side, one right over here from A to the other side. So that already meets up at that area right there where B is at. And then right over here, this line also has a point of concurrency also at B. So right here, this is our orthocenter. Okay. Now, along with these, we also have another set of theorems and a bit more information. So let's go through and take a look at the right side of our paper. So in an obtuse triangle, ABC, BD, this line outside of the triangle, is an altitude. So not every time that we have an altitude will it be inside of the triangle. Sometimes it is outside. So make sure you keep that in mind. Now, in the other picture here, we said in triangle ABC, BD, AF, and EC are the altitudes, and G is our orthocenter. So all three of those happen to be inside of the triangle. Now, the lines containing the altitudes in a triangle are concurrent. So BD, AF, and EC are the altitudes, G is the orthocenter. Now, there's no big math formula that we need to know from this. It's just important to know that even though this line here is going to be meeting BD at a right angle, that doesn't necessarily make this a bisector. It just means that this part here, these two lines, are perpendicular to each other. That's important for us to know, that these two meet at a right angle. All right. Now, along with this, it's important for us to know, depending on the triangle, our orthocenter is in a different place, kind of like what we have with the circumcenter. They're in different places for different triangles. So in an acute triangle, the orthocenter is going to be inside of the triangle. If it's a right triangle, the orthocenter is on the vertex of the triangle. So that vertex that we're looking at is the vertex that's opposite the biggest side, the hypotenuse. And then in an obtuse triangle, the orthocenter is outside of the triangle. So these do kind of mirror what we have for our locations from perpendicular bisectors. Now, occasionally you'll be getting lines as we're looking at these. We just got to go through and know which types of lines we're dealing with. So we're looking at both of these triangles, and we're going to determine whether or not it is a perpendicular bisector, a median, or an altitude. So looking at number A, we have this triangle here. The only things that we do know is that TQ meets up with RS at a right angle here. We don't know anything about the lengths of the parts of RS. So is this a perpendicular bisector? No. Is it a median? Also no. But it is an altitude. So these lines can be more than one of these at the same time, but it has to fulfill all the other parts that we have there. If this line here, TQ, was, QT, if QT was a median, this would need to be the midpoint of this side. And if this were the midpoint, this would also mean that this could also be considered a perpendicular bisector. It's not always going to work, but it's important for us to know if it fills more than one of these criteria, it could be more than one of these types of lines. Now, when we look at B, I see that TQ, I'm saying TQ again, aren't I? QT, my bad. QT meets RS at a right angle. It also is cutting RS into two congruent parts. So it is perpendicular. It is at the midpoint of this, making it a bisector. So it is a perpendicular bisector. If we look at where it is, this is coming from the vertex of the opposite side to the midpoint of the opposite side, which makes this also a median. And then finally, since it is also perpendicular and it is coming from that opposite vertex, this is also an altitude. So in this case, all three of these can be considered a part of this line, as opposed to this, where it's only one of them. All right, people, I appreciate your time. Make sure that you're doing all you can to review, and I'll catch you later.